Alright, welcome back everyone. Today we're starting 12.5 with recursive rules, day 1. So we're actually going to start this new section by taking a look back at what we've done so far and giving a new name to it. So everything we've worked on so far in chapter 12 with sequences and series, we've been using what are called explicit rules. It's what we've been working on so far. It's where you get to find the value based on the term's position. So you can find the nth term. For example, and this should look like what we've been doing, if it says a sub n equals 5n plus 1, and if I want to know the sixth term, then I just say a sub 6, where n is 6, and I can do 5 times n, 5 times 6 is 30, plus 1 is 31. So I can find the sixth term. Now I can leap ahead and find the 11th term. And I can do 5 times 11 is 55, plus 1 is 56. So it allows me to find whatever term I want whenever I want. And this is different than what we're starting here in 12.5, which introduces the idea of a recursive rule. So instead of an explicit rule, now we're working on something called a recursive rule. This gives you a starting term. It tells you where you're starting, and then you find the value of the next term based on the previous term. So instead of jumping around, instead of just picking, whatever term you want, you can only find the next one, and then you can find the next one and the next one. So for example, if they told us that we were starting with a sub 1 is 3, our first term is 3, and then if they told us that a sub n is equal to a sub n minus 1, that would be whatever came before. So a sub n is the new term, a sub n minus 1 is whatever came before, and we're going to take whatever came before and add 2. So I go, okay, if this is a sub 1, well, what about a sub 2, the next one? A sub 2, the next one, would be equal to, and then 2 minus 1 is 1. This is a sub 1, which is 3, and 3 plus 2 is 5. It's just telling us to go up by 2. So explicit rules are really helpful when you want to jump around and find any term you want, the nth term, and you can jump right there. Recursive rules are really helpful when you want the next term, when it's more like a pattern where you're not just skipping around, but you're interested in every single value one after another, then recursive rules become easier to use. So we're going to break this down into what do they look like when arithmetic or geometric, and here we can see what a recursive rule would look like for each of those. In an arithmetic function, it's a sub n, the next term, is equal to a sub n minus 1, the previous term, plus d. You're going up by a common difference, or of course if the common difference is negative, it could be like minus d, or plus a negative, then you're going down by. So every new term is you take the old one, and you use the common difference to move to your next term, just like how we work on patterns going back to earlier grades. For a geometric one, it's a sub n, the next term, is equal to r, the common ratio, times that previous term. So again, you just take the previous term, multiply by the ratio, you get the next one. Now take that one, multiply by the ratio, and you would get the next one again. So again, explicit rules, what we worked on before, really good for skipping around, getting whatever term you want. Recursive rules, really good for getting the next term. So let's go ahead and try a couple examples to wrap this up. We're going to work on 2 different problems. Write the first 5 terms of the sequence, and we'll start with the one written on the left here. So you see this one starts with an a sub 0 equals 1. A recursive rule is always going to have to tell you where to start. Because the rule itself over here, it only tells us how the next term and the previous term are related to each other. The next term is equal to the previous one plus 4. But if I don't know that previous term, I don't know what I'm adding 4 to. So that's why we have to know where to start. So a sub 0 is 1. Now I'm going to show the work for the next couple of them, but ultimately recursive rules are really good for kind of not showing your work and just working quickly and getting the next answer. So when I work on a sub 1, at first I'm going to use it like this rule says, and I'm going to say a sub 1 is the next term. Well, to find that I need to use the previous term, where 1 minus 1 is 0, and I'm going to add 4. Now I know that a sub 0, the previous term was 1, and 1 plus 4 is 5. So a sub 1 is 5. Now I'm going to do that again in a sub 2, and again I'm going to show these details for a couple of steps just till we get used to it, and then we can show, of course, how it's much faster to just go ahead and get the answer. A sub 2 is the next term, and then I'm going to use the previous one, 2 minus 1. I'm going to use a sub 1, and then I'm going to add 4. So I'm taking whatever came before. Well, whatever came before a sub 1 was 5, so I put a 5 right there, and 5 plus 4 is 9. I'm going to do this just one more time, where a sub 3 is equal to a sub 2 plus 4. That's the next term equals the previous one plus 4. Well, the previous term was 9, and 9 plus 4 is 13. Now, ultimately, look what emerges on the right here. 1, 5, 9, 13. These are our answers. This is a pattern that's going up by 4 every time. So, ultimately, all this work in the middle, it's nice to see, it's nice to know what recursive math looks like and how a new term is based on the previous one, and then the next one is based on what came before that, and the next one's based on what came before that. But ultimately, it's this common difference here, plus 4, where I can then quickly say, well, then the next one is 4 bigger, and the next one is 4 bigger, and I can get those answers much quicker that way. So let's look at one more on this side, where I can see that they're starting us, a sub 1 is 1, and every one after that, every next term, is 3 times the previous term. Now again, I'm going to show the math for a few steps, and ultimately it's going to be easier to just work quickly and skip ahead. So a sub 2 equals, the new one equals, 3 times the previous one. 3 times a sub 1. Well, a sub 1 was 1, and 3 times 1 is 3. So a sub 3 equals 3 times the previous one. 3 times a sub 2. Well, a sub 2 was 3, so this becomes 3 times 3 is 9. And again, I'm going to show my work just one more time, where a sub 4, the new one, equals 3 times the previous one. And so that's 3 times a sub 3. Well, a sub 3 was 9, so 3 times 9 is 27. Now again, nice to see that work, nice to know what recursive math looks like, but the whole benefit of recursive math is that you can very quickly find the next number. So 1, 3, 9, 27, they're all being multiplied by 3. Every new term is by taking the old one and multiplying by 3. So if I want this next term right here, I'm going to take the previous one, 27, multiply by 3, get 81. And if I want this last one down here, I'm going to take the previous term, 81, multiply by 3 for 243. So that's our introduction to recursive math. You can practice a few problems now on page 830, numbers 2 through 5 all. That's all of them, 2, 3, 4, and 5. Thank you very much.